All right, let's talk about Docker. This is a piece of tech that has, and I'm not exaggerating, totally changed the game for how we build and ship software. If you've ever been stumped by why an app works perfectly fine on one computer but just completely falls apart on another, well, you're about to find out why that happens and how Docker fixes it.
See, before we can even get to the solution, we really have to understand the problem Docker was built to solve. It's this dilemma that's been the source of headaches and late nights for developers for, well, decades.
Okay, picture this. A developer spends weeks, maybe months, pouring their heart and soul into building a new application. It works like a charm on their laptop. So they hand it over to a teammate, or they push it to a server, and bam, it just breaks. Everything grinds to a halt. Have you ever heard them say this next line? I bet you have.
Ah, yes, there it is. The famous last words. But it works on my machine. You know, that single phrase right there, it captures the entire problem that Docker was designed to eliminate. It's the chaos of having inconsistent environments. Different operating systems, different versions of software, totally different configurations. They all just plot together to break your code. So how do you fix that? I mean, how can you possibly guarantee that software that works on one machine is going to work on every single machine? The answer is actually pretty brilliant and surprisingly simple. You put your software in a box, and we call that box a container.
So a container is basically the standard self-contained little package. It bundles up an application's code along with every single thing it needs to run. We're talking libraries, system tools, settings, you name it. It's all in there. This whole package is isolated from everything else, which guarantees it's going to run the exact same way no matter where you put it. It just works, period.
Now, right about now, you might be thinking, hold on, isn't that just a virtual machine? And that's a great question. But nope, not quite. And this difference is absolutely crucial. Virtual machines, or VMs, are heavy. They're bulky. Each one has to run its own full copy of an entire operating system. Containers, on the other hand, are incredibly lightweight. Why? Because they all share the host machine's operating system. This makes them way faster to start up, and you can run a whole lot more of them on the exact same piece of hardware.
So this whole lightweight, portable nature of containers, well, that's what gives Docker its superpower. It's not just about solving that works on my machine problem anymore. It's about making the entire process of creating and deploying software so much smoother. It really boils down to three huge wins. First, you get super fast, consistent delivery. That's because everyone, from developers to testers, is using the exact same standardized container. Second, deployment and scaling are incredibly responsive. You can spin up new containers or shut them down almost instantly to handle changes in demand. And third, because they're so light, you can cram way more applications onto the same server, which, as you can imagine, saves a ton of money.
So what does this actually look like in practice? Well, a developer writes code inside a container right there on their laptop. Then, that exact same container gets pushed to an automated testing system. If a bug pops up, it gets fixed right inside that container and redeployed for more testing. Once it passes everything, that very same, fully tested container is what gets pushed out to the customer. It's one consistent environment, from the very beginning to the very end. No more surprises.
Okay, so we get why Docker is so powerful, but how does it actually work under the hood? It all comes down to a really simple but very effective client-server setup.
It all begins with you. When you open up your terminal and type a command like Docker run, you're talking to the Docker client. You could just think of it as your remote control for the whole Docker system.
But the client isn't the one doing the actual work. It's more like a messenger. It takes your command and sends it over to the real brains of the operation, the Docker daemon. And they talk to each other using something called a REST API, which is just a standard way for computer programs to communicate.
The Docker daemon is the true workhorse here. It's a service that's always running in the background on your machine, just listening for instructions from the client. When it gets a command, it's the one that does all the heavy lifting, building your containers, running them, and managing all the different pieces.
And what is it managing exactly? Oh, just all the most important stuff. We're talking about images, which are the templates, and the containers themselves, the running apps. It also handles the virtual networks that let containers talk to each other, and the volumes, which make sure your data doesn't just disappear when a container stops. The daemon really is the master controller of this whole universe. All right, if you want to truly get Docker, you have to nail the difference between its two most fundamental pieces, images and containers. And honestly, the best way to think about it is with a super simple analogy: blueprints and buildings.
A Docker image is the blueprint. That's it. It's a static, read-only file that has all the instructions for creating a container. It's got the operating system, the application code, all the libraries. Everything you need is spelled out right there in the plan. So if the image is the blueprint, then the Docker container, well, that's the building. It's a live, running instance that's created from that blueprint. You can create them, start them, stop them, delete them, and here's the cool part. You can build many, many buildings or containers from just a single blueprint or image.
Okay, let's watch this all come together with one simple command: Docker run Ubuntu. So first, Docker checks if it has the Ubuntu image, the blueprint, on your local machine. If not, no problem, it just pulls it down from an online library called a registry. Second, it uses that blueprint to create a brand new container, the building. Third, it slaps a writable layer on top so your app can actually create and modify files. Fourth, it sets up a network so the container can talk to the outside world. And finally, it starts the main process inside. All of that happens from just one command. It's a complete running system in seconds.
So here's the bottom line. Docker gives us a universal way to package and run our applications. It crushes that works on my machine problem and streamlines how we build software in a way that, not too long ago, was just a dream. So that leaves us with a really exciting question. If any application, from a tiny website to a massive AI model, can be packaged up to run perfectly, anywhere, what will we build next?